It's high on a mountain, the warm winds are blowing, and where the winds are blowing to, there ain't no way of knowing. The mountain grass is short, it's dry and close to burning, crying out for water as the season's turning. Sweet smell of the pines, tall western cedar, drifting on the wind through the mountains like a river.
Hello, and welcome to Unlearn and Rewild, where we explore radical ideas relating to Earth renewal. On this program, we speak with authors of many disciplines, activists, cultural figures, mystics, philosophers, scientists, and other weavers of vision for an ecologically based society. Today, it's a thrill to be speaking with Dr. CURT STAGER about his 2011 book, Deep Future, The Next 100,000 Years of Life on Earth, and his brand new book, Your Atomic Self, The Invisible Elements That Connect You to Everything in the Universe. CURT STAGER has a PhD in biology and geology from Duke University. He has published more than 36 climate and ecology-related articles in major journals, including Science and Quaternary Research, and has written for popular audiences in periodicals such as National Geographic. He teaches at St. Paul's College in the Adirondack Mountains of upstate New York, and he holds a research associate post at the University of Maine's Climate Change Institute, where he investigates the long-term history of climate in Africa, South America, and the polar regions. He has also produced Natural Selections, a weekly radio short on North County Public Radio for the last 25 years in New York. Thank you for being on the program, CURT.
Oh, happy to be here.
It's exciting to talk with a paleoclimatologist, ecologist/geologist, and to ask similar questions we might ask to a mystic philosopher, and to hear similar or at least complementary insights. You're a champion of new paradigms in science, and having studied in the old paradigm and experiencing this shift during your career, I'd love to hear about how you came to grasp the connections between living things and between ecological processes and the continuities throughout the universe.
Well, it was a gradual process, really. It's sort of a lifetime of interest in trying to find our place in the world and in the universe, where we come from, who we are, and things like that. So it was sort of an evolution, I guess, would go way back, decades and things. But just little by little, doing my research into climate history, environmental history over centuries and thousands of years around the world, you get used to imagining the hidden connections that really are there and can be traced with science. And one of the things that goes with ecology is the movement of matter and energy through food chains and around the planet. So you start getting familiar with things like phosphorus and carbon and where they're moving around, and then eventually you start realizing, gosh, I'm made out of that stuff too. And that's kind of what the transition was. Doing Deep Future was sort of following carbon around the world and seeing how long our carbon pollution will be around. And that was a real eye-opener. The atoms are really permanent, and the CO2 combinations that trap the heat are here for much longer than we thought. But that then got me used to thinking on the atomic level. And then I realized, well, gosh, if we can learn to see that infinitely small, invisibly small stuff that really only science can help you detect, it actually shows you that a lot of the old traditions of being connected to the world and to each other were correct, but we can now nail it down with precision with science too. So it adds strength to those kinds of profound insights.
You write about deciphering the unseen realities using the tools of science, and this passage from your book sums up the message. Quote, "Rather than rely solely on our limited senses as early ancestors did, we can now use new information about the previously hidden atomic nature of things to better interpret what our senses tell us, and we may hope to produce more sound and sustainable ways of living as well." So what is this?
It's kind of ironic. You think with this modern science you would get more and more isolated from nature or from these sort of old, I suppose you could call them animist views, where people shape-shift and turn into owls and other creatures and things. But in fact, in a way, the science, once you really dig into this, is showing us, it's kind of taking us back to those views again. And it's just a really exciting time.
Waska runa sita shamu ikaromai. Waska runa sita shamu ikaromai. Silo ayawaska. Silo matang ayawaska, waska sita. Silo ayawaska, reina de...
The Harvard conservation biologist E.O. Wilson said, quote, "Perhaps the time has come to cease calling it the environmentalist view, as though it were a lobbying effort outside the mainstream of human activity, and to start calling it the real world view," unquote. I think the message of interconnectivity that science is revealing is redefining environment. The environment includes human habitat, future worlds, past worlds, and many people inhabit virtual worlds these days, all of which need to be considered while moving towards a regenerative society. I'd love to hear your take on what stands in the way of an ecologically based society, and what we need to do to overcome it. E.O. Wilson wrote about a truly radical plan to limit human activity to half the Earth, while conserving the rest of the Earth for the other 8 million species. What would you offer to this discussion?
Well, these are enormous issues, and the world is more complicated than any one person can grasp. Even some of these narrower topics of, how can you be a pile of atoms and yet also be yourself and be connected to all these things through time and space. So I think it's important, number one, actually, to learn how to communicate with each other in a civil manner so that all of our different brains can come together and figure these things out. Like, I absolutely admire E.O. Wilson. I think he's a genius and a visionary and a real important person to listen to, and yet even he can't figure out if, really should we do the 50% of saving it for us and the other half for other species, or maybe somebody has another idea. So I don't so much have the exact solution for what the best ideas are to do, but what I'm feeling like is it's very important even just to understand what the situation is. And a lot of us aren't there yet. So maybe one way to think of it is by looking at longer time views than we normally do, or looking at ourselves in the context of the atomic world. Those kinds of things, I think, are transformative and important. And if we can get more people thinking along those lines, which, as Wilson says, is actually the real world view, then I'm hoping we can all come up with better ideas from all of us as to what to do. So maybe one way to look at it is by doing this, I sort of feel like I'm a map maker. I'm trying to map out what the real physical reality is with the help of science and such, and then passing that around, hoping that we get some very capable navigators too to use that map.
Another aspect of humanity's influence in this Anthropocene era is our meddling with the nitrogen cycle. Half of all nitrogen is now man-made using the Haber-Bosch process, where we artificially pull nitrogen out of the atmosphere for use as fertilizer. And also, half of all the protein in human tissue was originally made this way. So what would happen if these industries had to go offline and we stopped fixing nitrogen? Would it take a while to regain the balance and have any ecosystems become dependent on our man-made contributions?
Well, this, interestingly, of looking at our atomic connections to the nitrogen cycle really opened my eyes to something I never thought I would come around saying. I'm so interested in what you might call the natural world, the forest and the lakes and the oceans and things. But really, I feel like in this new epoch of Earth history, this Anthropocene epoch, the age of humans, we're realizing that we really are not distinct from nature, and we're just as much a part of it. We're made of the same stuff as all the other species. And so I've been increasing my empathy and sympathy for the human race by doing this. And so when you find something like half of the human bodies on the planet couldn't exist without this technology of trapping nitrogen from the air, which otherwise couldn't be done without the help of bacteria, basically. If we stop that supply, probably half of humanity would die in a very short time. I wouldn't consider that a good thing. Maybe you can sort of chuckle and roll your eyes. Oh, wouldn't it be nice if there weren't so many of us? But, let's talk reality here. What a horrible, horrible disaster that would be. And what sustains that is the human version of ecology. It's civilization, where we all interconnect just like other parts of any ecosystem and sustain all of our lives. And so I feel like we need to see our place in the big picture so that we don't damage the environment that we need to keep us alive, and see the value in the connectedness to the rest of the species and the rest of the ecosystems, so that we don't destroy one while trying to favor ourselves. But right now, basically we're running around with, you could say, heavy equipment blindfolded, not realizing what we're damaging and what we're about to run into with all this stuff. We need to open our eyes and learn how to do this in a conscious level. And science is our clearest window on this truth. So again, getting back to the basics, I feel like even the struggle of getting people to acknowledge that science is so important, a very precious gift, not just for our civilization and our technology, but now for the whole planet. I feel like that's an important mission and an important challenge.
A really neat thing you wrote about is how plants and fungi are constantly excreting enzymes that break down rock. And apparently every year, 20 billion metric tons of rock is broken down and washed to sea. According to one article you reference, the continents are being ground down in this way so much that Earth's molten mantle churns more violently. What are the long-term implications of this? Could the continents theoretically grind away ad infinitum, except where volcanoes can form new land?
Mm-hmm. Yeah, it just makes the world an amazing place. If you can see this connection of something as small and slow as lichens slowly grinding down the face of a boulder when you're walking past it in the woods, and seeing what that adds up to, like you said, it can change the circulation of the Earth's mantle and the drifting and erosion of continents. So that is pretty amazing. But as you continue along that path of kind of grasping what that's all about, you realize, this is actually what has been happening ever since life's been on Earth. We've had the continents drifting around, and you can even look up maps of where we think they were and what they used to look like and things like that too. So this actually is what it's like living on a partially molten planet. And you can even look at it, if you hunt around online in this topic, you can find maps of where the continents are likely to be in 1 million, 10 million, 100 million years as well. So that story's not over by any means.
I live on the West Coast, and I'm completely in love with the temperate rainforest. There's the largest trees in the world here, although only a few % have been spared the furious logging of the last century and a half. British Columbia has by far the largest remaining ancient forest, with 53 million acres relatively untouched in the very steep, wet coastal mountains. All the rain helps, but the real growth factor is the compost. Every year, salmon spawn up countless rivers and streams to lay their eggs and die, and their nitrogen-rich flesh ends up in the trees. So can you explain this incredible process and how we can reconstruct the history of salmon through tree rings and lake sediment analysis. And from that research, are there any clues about the current decline of salmon?
Sure. I was just blown away by the ability to trace the atoms from the ocean into the fish, then up the rivers, into the bears that eat the salmon, and then the other things that eat the wastes and the leftover salmon pieces that then turn into flowers and trees, to the extent that then you can take a little section of a tree trunk and look at the rings of wood that were laid down year after year and watch the amount of nitrogen-15 fluctuating from year to year in the rings in just the same way the abundance that the salmon did on those salmon runs from year to year. So in a way that they call them salmon forests for that reason. The atoms in the trees are former salmon atoms. So that alone was pretty mind-blowing. But then to move it on, as you suggested there, to my research specialty, which is looking at sediment layers under lakes and reconstructing history that way, you see a similar thing in the lakes. When salmon would come up and spawn in the lakes, their atoms would remain in those sediments too, and you can count them back even farther than the tree rings. So this then leads from exploring the atomic world to exploring deep time again, because some of these cores go back thousands of years. And the study you reference had a really, really interesting finding, which is if you look what we normally consider to be long-term, the last few decades, we've got this decline in salmon. And you may remember hearing stories maybe from older folks or Native American traditions saying, in the old days, the salmons were so numerous you could walk across the river on their backs. Things like that. So we say, well, gosh, the normal state was millions of salmon, and now we're losing it, so it's got to be us. And that's probably true in this case. But if you look over the long term, you find out about 2,000 years ago, there was a gigantic drop in the nitrogen-15 concentrations in the lake sediments. And the most reasonable conclusion is the salmon almost disappeared way back then for centuries. Which then raises a really interesting question. Number one is, well, gosh, what made that happen? And we still don't know to this day why that happened. That's work in progress. But the other funny thing is, maybe it was strange that there were so many salmon a century ago. Maybe that wasn't normal. And it makes you wonder, well, then why were there so many? And we don't even know that. Which then raises the question of what do we really know about the fish and their place in the world, and what can they sustain? What really does make them healthy or numerous or rare, and shows that we really still have a lot to learn about how the world works.
I'd like to turn to your book, Deep Future, and in your book you go way past the typical time frame of climate prediction. So what if we zoom out to 100,000 years? What kind of climate trends do you think the Earth will see?
Well, that was what really got me to want to write the book. Was there are climate researchers for the last 10 years have been mapping this out in ways that are just mind-bending or astonishing, and yet they're founded in relatively simple, rock-solid scientific concepts. And the basic one is, remember that these greenhouse gases are made of atoms and molecules, and those atoms and molecules don't vanish when they go in the air. They stay around on the planet. So in theory, you should be able to trace where they go, just like the salmon nitrogen, and in fact, we can. So by doing just a little bookkeeping, these folks are measuring where the carbon will go and how long it takes. And the most obvious place, first of all, is the oceans, because water absorbs gases from the air. So most of it's going to end up in the oceans, between 3/4 and 4/5 of it. The rest is going to be stranded in the air, kind of like leftovers from a big old banquet when the oceans are full of it, and will slowly be reacting with rocks and soils on the dry land and taking the carbon out of the air that way, then slowly washing that back into the oceans with rivers and such, kind of like an antacid pill so the ocean can take up the last bits. So those are the two places, the oceans mostly, a little bit on land that then delivers it to the ocean. But the most shocking thing is how long it takes. So for the oceans to absorb most of the stuff so they can't take anymore is on the order not just of decades, the end of the century, it's thousands of years. And the reactions with the rocks and the soils is tens of thousands of years to finish that job. So when you add it all together, the choices we're going to make in the next few decades are, if you want to simplify it, you could say we either switch from these fossil fuels quickly, in which case we won't release all of the fossil carbon that's here into the air, or if we go ahead as we basically are now and just go and go and go until we have to switch because we burned it all. Depending on which of those two choices we make, either way we're still going to have to switch from fossil fuels. But if we take another century or two and burn the stuff, the difference is enormous. The least impact we would have is the quick switch, in which case things probably won't come back to the way they are now for between 50,000 and 100,000 years. And that's the mild case. So it's virtually permanent on a human scale. But if we go the profligate route and burn as much as we can and then are forced to switch later, the impacts are much, much larger. We'll set in motion other processes that amplify those changes, and the recovery probably won't be complete until maybe 500,000 years in the future. It's fascinating, depressing, and exhilarating all at once. I find it fascinating as a scientist. It's like, wow, how can you even figure this stuff out? But, oh my gosh, study after study shows it, and of course it even makes common sense when you really think about it. And then the depressing thing is, oh my gosh, what have we done? You know, that this is so huge, and it's big, too big for most of us to grasp, because we're not used to thinking in these big numbers. And it's so huge it moves slowly on our time frame, which makes it easy to think it's not happening. Like there's no urgency because I can't see it happening. Well, you know, every decade we continue just amplifies this effect for thousands of years. And the exhilarating part gets me back to this civilization thing and seeing our place in the world. Once you kind of get over the shock, you say, well, gosh, you know, look at the huge impacts we're having without even trying. We're not doing this on purpose. It's happening blindly. Can you imagine the power we have to do the right thing if we know what's going on, see our place, and do the right thing? And there's this great quote that I think sums it up. It's from the 1800s, a scientist called Thomas Henry Huxley. He was involved in a controversy of his day, which was Darwin and evolution, and he was defending Darwinism, and people said, well, why do you even like this topic? You know, when you argue, it just upsets people, which is what you might say about climate change, right? But he said, we have to know what is true in order to do what is right. And I feel like that's a great motto for us to really face facts, see how powerful we've become, maybe be a little scared by the effects we have on the planet, but not be paralyzed or depressed by the fear. Instead, be empowered to realize what a powerful force of nature we've become and what a force for good we can be. We are in this amazing time in Earth history. Literally, the generations of people on Earth today are going to make decisions that are going to echo on down into the future for tens of thousands of years. So that means every single one of us is hugely important. And we're interconnected into this global system of an empowered human race. So literally, the contents of our hearts and our minds are huge forces of nature. And so therefore just simply, like I said, cleaning up and focusing on what's in our heads and knowing what's going on is really, really important.
So much of the climate denial and failure to act comes from, a lack of clarity on where we're headed. The predictions vary wildly. Should we be preparing for a temperature spike or, a polar vortex-induced ice age? What is your current thinking on where the climate is heading this century?
Well, the current thinking is, although, when you have a weird year of weather, it makes headlines, and sometimes the weird weather fits the big picture, like, oh, you have these hurricanes, that you probably expect some of those from a warmer world, and yet now we've got, like, wicked cold, right? So how's that fit? You can take this short-term thing people are talking about, oh, did global warming stop in the recent years? It's like, no, it didn't. The heat's going into the ocean, and when the currents change around again, we're going to be warming again like we were before. The real big picture long-term thinking is, okay, let's not get distracted too much by these short-term things, even over a year or two or even a couple of decades. That's weather we're talking about there. The climate stuff is big. It's global type averages over large areas. And that's the scale of things we're talking about with the future and the carbon and things. So the latest thinking, as best I've been able to find in the literature, is we're not going to see an average change of the world overall that's going to be wildly different from what we know until another few decades, probably mid-centuries, when you're finally going to say, yes, okay, it's definitely global warming on average, and it's really due to us, and the world has changed measurably, noticeably, and consistently from the last century. So these are things that are playing out over the giant scale. We're not going to trigger an ice age. We're stopping ice ages with this. In fact, we've already stopped the next one, pretty certainly. You can see the natural cycles that make ice ages come and go. And the next one, without us on the planet, let's say, would have happened in about 50,000 years from now. And even in the mild case of us switching quickly from fossil fuels, there will be enough extra fossil carbon in the air to trap enough heat to raise the Earth's temperature just enough, even 50,000 years from now, to stop that next ice age. Which I guess you could say is a good thing if you live in Canada, but, again, to show us our power. But the ideas of triggering an ice age and things, those are from movies and some ideas which are sort of taken out of context from the scientific literature. There was one cool event in the North Atlantic, for example, near the end of the last ice age from some giant flooding events from meltwater, and it did cool things in certain parts of, like, Europe and stuff. But that was, way blown out of proportion, kind of in the storytelling modes.
So by mid-century, we're going to definitely see that we're in a state of warming.
Oh, yeah. I mean, you can sort of sense it now, but, people like Jim Hansen that get a lot of credit or blame, you could say, for being the first to announce that global warming is real. He may turn out to be right, but that was not a scientifically well-supported, solid claim. He was gambling on that, but to really have it nailed down as there's no question the average trend, blah, 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 these are slow and large, things, that it makes sense that by mid-century it will definitely not just be year-to-year variation or sunspot cycles or any of these. The whole baseline will be noticeably warmer all around the planet. And, of course, sea level is going to be going up even after the temperature peak, right? Because it'll be hotter than now even after the peak passes. So the ice will continue melting even while the temperature recovery is happening. So sea level is just going to be going up and up and up and up. Go see the Everglades while you can.
I was just actually down in southern Florida, and it was really kind of a mind trip to see homes and high-rises and all these buildings literally built on the sand. I thought to myself, oh my gosh, so much, not just Florida, but so much of the world's large cities are built on waterways.
Sure.
And what a unimaginable world that would look like.
Well, you can see the practical effects of the dangers of not using long-term thinking. Exactly what you described, building on beaches, building on floodplains. You think about it, people found places to live during the short time span of their active lives, let's say, and gosh, look at this place, there's a river right there. That's neat. And look at all that flat land around it. What a perfect place to build a house, and then a town, and then roads, and isn't that great? And then you never stop to think, why is the land flat all around that river, And so when it happens, because we're still in this short-term thinking, you call it like an act of God, a disaster. No, it's a floodplain.
Right.
If you build on it, this is going to happen. And same with the beaches. Only now it's permanent, virtually, because the sea level's coming up and is going to be doing it for centuries. And so progressively, on average, the flood events from hurricanes and things are just going to get farther and farther and farther inland. You're living on borrowed time if you build on beaches now.
I remember maybe a few months ago there was a National Geographic map. They had this huge pull-out map inside that was showing time increments and sea level rise around the world. And it was really jaw-dropping. So much short-term thinking. It's a lesson learned, or will be learned.
Yeah, it's a matter of life and death to not think long-term in those habitats especially, to not realize that it's not a question of if, but when the big one is going to come.
She was always walking, singing to her footsteps, dirt ditch paths and pine cones, digging up glass bottles, rusty springs from feather beds, old hubcaps on the picket fence. She planted beds of flowers, stayed outside for hours. In spirit, she's drifted to the ocean.
Going back to the topic of the temperature rise, what do you make of James Lovelock's theory that the Earth could tip to a hot state that's inhospitable to intelligent life?
Well, if you look at the facts and figures that I present in the book, I went through a large part of the scientific peer-reviewed literature on this to get these estimates of the warming. And Lovelock's original estimates of it killing billions of people, even he has backed away from those now. Jim Hansen also had a thing called the Venus syndrome, which he put in his book, What is it, Storms for My Grandchildren, I think it's called. Terrified a lot of people. And his idea was, having studied Venus before with his research, he said, well, gosh, maybe we could have a runaway greenhouse, boil off the oceans, put all the water in the air, and that makes a super greenhouse, and all of life on Earth will be killed. He has backed off from that, too. It's not going to happen. And a lot of us would say, well, that's kind of gives science a black eye at a time when we need to really be taken seriously. We don't need the extreme stuff to acknowledge the seriousness of these issues. And even if it's slow, even if people are around, like, as I said, Lovelock has backed off from that now, and even he says this, the extreme alarmism is a disservice, actually. But if you think about it, it's not saying don't worry about it. Maybe one way to say it is, just to say that people are going to live through it sounds like, well, don't worry about it. No, people will live through this. It's not something that's going to happen to an uninhabited planet. The things we're setting in motion in the far future are going to be endured by people. It adds a stronger ethical dimension, if anything, to what we're doing. We're affecting the grandchildren of our grandchildren's grandchildren.
By mid-century, what type of temperature rise are we expecting, and why does that matter to people when people are just thinking, oh, it's, warmer winters?
Right. Well, it's important not to be too broad brush with some of these things. If you warm the average temperature of the planet, first of all, don't forget, individual locations will warm more or less. Like right now, there's no question global average temperature's gone up in the last century, but there are certain places like northeastern Canada, because of the ocean currents, has not warmed significantly. And so there will be places on Earth that you could argue would become more habitable. You know, that's no argument for not doing something to stop it. I mean, first of all, there's a million reasons to switch from fossil fuels anyway, for economic reasons, social, cultural reasons too. But, I mean, when you change the average temperature of the planet, you're not just raising the thermostat and everything goes up the same amount, the small amount. It disrupts entire ways things operate. So you change wind tracks, for example. So it's likely the westerly winds that bring most of the rain and snow, let's say, across the middle of North America, they're likely to shift more towards the north. And it's even more likely that's going to happen in the southern hemisphere. And that alone, just shifting where the winds blow, as the winds move closer to the pole, let's say as the things warm up and the ice goes away, well, like one example was my research in South Africa, looking at the climate history. When it gets warmer in the past, the rain that only hits South Africa, that kind of arid, beautiful place where people in the landscape really depend on the winter rains because there's almost none any other time of year. It's winter when those storm tracks kind of brush against the southernmost tip of the continent. If you pull those closer to Antarctica, they won't hit South Africa anymore. And then there won't be any rain at any time of year. So a shift of a small amount of temperature can have massive local effects from things like that. And so for people to belittle it just shows they don't know what they're talking about. It's, again, not, short-term thinking, small thinking, or not thinking clearly at all.
Something I think about is with the temperature rise, the inability to grow native plants in their native regions, biodiversity loss. But then you throw in the wind and the rains and...
Come back to this idea of, should we be depressed and alarmist and stuff? You can point to Greenland and say, well, it's great for the native folks there in a way because, as the ice shrinks and it warms, they can grow vegetables more and you get fresh food that can only be brought in at great expense now and all these knock-on positive things. But if you're really thinking the big picture, who has the right to make these decisions for everybody in the world? And yes, maybe Greenland benefits, but is that ethical to give them that boost by taking away the rain from South Africa? We need to see the whole picture here, and the science really helps us do that.
You were recently doing research in the Peruvian Andes, where many of the tropical glaciers are endangered, and several have completely disappeared, forcing indigenous farmers to relocate to find an irrigation source. With the uncertainty around fresh water, I'm curious what will happen to precipitation in the tropics this century, in particular in the Amazon, where there's massive tree death and drought-related fires.
Yeah. Well, unfortunately, we don't have 100% reliable models yet. The temperature stuff is not that difficult to model, and you could sort of almost do it in your head, right? I mean, the air mixes completely, within a year around the world, and if you put more greenhouse gases in it, the average temperature goes up. I mean, I could have told you that without a climate model, right? But precipitation's really complicated. It has to do with how much evaporated here, and then where does it go on the air from there in vapor form, and then what cools it enough to make it condense. Was it uplift? Was it, all these different things? And if you think about it, just how rainy weather works, you could be sitting here and get a big deluge on you, and the person the next town over didn't get any. And your two towns would then register a dry summer or a wet summer, and they're almost a walking distance apart. So imagine that complexity. And then try to map it on a global scale, and the models just fall flat with the rainfall stuff. So always be careful of that. If someone says, the model told us the Amazon's going to get wetter, the model told us it's going to get drier, you say, well, which model? And what are its strengths and weaknesses? And so we actually don't even I've heard conflicting weather analyses for the Amazon, even the historical measurements as to whether as a whole it's getting wetter or drier. It's probably a patchwork here and there. And so we really don't know exactly, but there are some common sense generalities you could make. And one of them is, if the air's warmer, the oceans get warmer. And if the oceans get warmer, they evaporate more. So that's common sense. So more vapor in the air, on average, should mean more intense, heavier precipitation on average in the places where it happens. And some of those places are predictable, like in the middle of the tropics, you got these air circulation systems that have warm, moist, rising air, and they make the monsoony kinds of rains. So common sense is, probably a lot of those are going to get wetter. And then there are opposite places where the air is sinking and drying and cooling. So you say, well, gosh, maybe the dry places are going to get drier. But then you also have the shifting of the winds. So my best guess from looking at these conflicting climate models, let's say for Africa, where I did most of my work, is a lot of the inner tropics might get more moisture on average, although we don't really know, but just guessing, probably on average more of that, which could be good in a way, but also bad with flooding more and insect-borne disease. And then the dry parts, which are farther out from the equator, like up near the Sahara and then down south near the Kalahari, if the wind belts are shifting towards the poles, those could spread north and south. So maybe like northern Africa, parts of Morocco, Libya, Egypt, that get some rain sometimes now, maybe those rain belts will be pushed off the northern part of the continent into the Mediterranean or up into Europe. So these are just things that we can only speculate about, but common sense, broad brush things like that maybe are better than some of the models right now.
If hypothetically the Amazon dried up in the next few decades, and then rainfall patterns changed, and it became wetter again, would the biodiversity return, or would we be looking at a novel ecosystem with a less diverse species composition?
Well, you can't have the trees without the water. But it's important to remember, again, if you have this picture of us being in this new epoch of Earth's history, this is the Anthropocene epoch. We've had dry times and wet times before. We've had hot times and cold times before. What's different is we are all over the planet with our technology and our settlements and our interconnectedness. So in the old days, if you had a massive climatic shift, which did happen in the Amazon and did happen in the rainforests of West Africa, it was the last ice age. When it got cooler on average, the monsoons were almost shut down in a lot of ways, and the rainforest gradually over the centuries, they shrank or they moved and things like that. So in theory, if things didn't happen too fast, maybe that could happen again. But the problem is, in this Anthropocene epoch, there's nowhere to go. We're in the way. Our farms, our ranches, our towns, our roads and things are blocking the one big adaptive tool that life on Earth has always had. It's the mobility. And plus we do other things, right? Besides climate, we can cut the trees and move things around and pollute things. So really it's the big picture of who we are, how do we run our civilization, and how do we see our place on the Earth that's going to determine this as much as the climate alone.
Onward from vast uncharted space, forward through timeless void, into us all their surge and race, the measureless might of the wind, in the steep, steep silence of thin blue air, high on a lonely ledge, where the air is clear and clean and rare, I give to the wind my pledge, by the strength of my arm, by the side of my eye.
Like you were saying earlier, climate change will bring some surpluses with the shortages, such as extra glacial melt water for farms until the glaciers are gone one day. And it'll be tempting to accordingly scale up agriculture and keep feeding a population boom. But you caution multiple times against short-sightedness and call for building reservoirs and canals. We recently spoke with Mark Shepard, who spoke about the strategy of keyline design to slow the water down, to contain and soak in as much water as possible, which is being used to restore desertifying landscapes far and wide. But what are some of the other short-term bonanzas that climate change may bring? An ice-free Arctic comes to mind, for example. And how can these new conditions factor in a long-term sustainability plan?
Right, yeah, exactly. Well, there's the science, where are the rainy or drying places? Where are the warming and cooling places? Where's the ice melting? How's the sea level coming up? These are mechanical things that a scientist, a map maker like myself, you'd say, could map out for us. But as I was sort of alluding to before, we need not just the map makers like myself, but wise navigators who know what to do with that information. And so the key here is not just what are the physical constraints of our environment and our effects on it, it's how do we think, act, and respond. So when you see a short-term bonanza, well, maybe if you were really smart about it, you could take advantage of it, but be agile and say, well, be ready to move on because it's only short-term and then we're going to have to adjust. But how do you make people do that? Or should you make people do that? And who decides these things? And who's going to carry it on from generation to generation? These are things that you figure out by being a human being in the Anthropocene, where you learn how to communicate with each other and respect science, but also learn how to be a citizen of the planet. So it's not just science. It's human interactions and human values and human ethics that are now built into the ecology of the planet. So maybe one way to sort of sum this up is, people say, like, how many people can the planet support, or, can we save the Amazon but also farm it? Or it's well, if you do it wisely with the big picture in mind, sometimes you can pull this stuff off and still have lots of people. But it's how you live your life. So one way to think of it is, you have a lifeboat out in the ocean. You've had a shipwreck and you're in this lifeboat. Okay, well, if you could cram, 24 people into a lifeboat if everybody cooperates and you share resources and help get water and trap it when it rains, and you help each other, you could make it to shore eventually. So it's not just what is the situation or just how many of us are, it's how we live our lives and what our perspectives are and what our ethics are. That's a real key thing. So I think the big take-home message of science in the Anthropocene is we are part of nature too. And so therefore, the more we can learn about ourselves and each other, the better off we're going to be too.
Many of the variables we're discussing are within our control, and many are way out of our hands. And I believe that we should do everything we possibly can to safeguard living communities. And we should go out on limbs and take on things that require a kind of faith that society will eventually join in. I'm interested in the question, though, what would happen climatically if we do nothing proactive and continue business as usual?
Mm-hmm. Yeah, isn't that ironic? If you put it that way, it sounds like you could describe it as, gosh, what if we just take the simple, non-dramatic route and just keep doing what we do versus the radical thing? And then you think, no, that's backwards.
Right.
If we keep doing what we're doing, that's the radical decision, because the consequences are enormous. I mean, not only this, 500,000-year recovery as opposed to, 50,000 or 100,000 years, but the scale of the warming. I mean, we will lose all ice on the planet if we do this. The sea level will come up 230 feet. The continents will be smaller. It's not like there'll be tiny little islands, but, Florida won't exist. It'll be a sandbar off the coast of that corner of North America. I mean, that's the radical stuff. But because it's spread out on this gigantic time scale, it's hard to see it as that. So, yeah, if we go on about business as usual, we are heading for the extreme version of runaway climate change.
What do you make of methane releases that are happening in the Arctic? Does the clathrate gun potentially represent an all bets off situation?
Yeah, that's an interesting idea. I spoke with one of the fellas some years ago who was sort of involved in this whole discovery of how much frozen methane there is in the ocean sediments and the permafrost and things like that all around the world. Just stunning amounts of natural gas. And this isn't the fracking stuff. This is meltable methane ice. Like, in theory, if you can pull it up from the ocean floor, and you can make snowballs out of it and then ignite the snowballs and throw flaming snowballs of methane ice. But the scale of this means that it's an important climate-changing gas. And it looks like 55 million years ago, something happened to release a lot of that stuff into the atmosphere, and we had a runaway giant global greenhouse. So the question is, could we do that again now by warming the oceans and the air and thawing the permafrost off? So coming up with that idea when it was new, said, well, let's make a dramatic term for it. We'll call it the clathrate. Well, clathrate is the methane ice. They say this is the clathrate gun, and we could fire it off by warming the world, thawing this methane ice and letting it into the air, and it's a giant greenhouse gas, and it'll just kind of get away from us and sort of, you say, blow up the climate or something. But the question now is, how likely is that to go off like a climate gun all at once? And that's an area of active investigation now. The question is, where is all of this ice, and how well insulated is it? And if it's under hundreds of feet of mud or hundreds of feet of peat, it's well insulated. So some of this stuff, we've had warmings before between the ice ages. Some of this stuff has been through, multiple ice ages and didn't thaw all the way down through. So some of the researchers are skeptical that we should maybe think of it as an all-at-once release that we're headed for, more like a clathrate dribble. But the fact is, we don't really know. And that's one of the things that makes it a little bit unnerving, to have such a big thing there that we don't fully understand yet.
To get a glimpse into your career, what are some things you could share about your recent research?
As far as critical findings in my new research go, I've been looking closer to home recently with my sediment core studies, and I live in upstate New York in the Adirondack Mountains, and we have 3,000 lakes and ponds around here. And I was realizing we know less about this corner of the world than we know about Africa, where I was working before, in Peru. And so I've been literally digging around here in the Adirondacks with my students and colleagues, and boy, we're finding some really interesting things about climate in this corner of the world over the last 1,000 years, especially that have to do with rainfall. So one of the big things that these are preliminary, but it looks like it's right. In lake after lake here, when we pull up these cores, there are these sort of, you could call them breaks, little hiatuses in the sediment layers when you get down about the mid-1700s that are look pretty much like a gigantic drought happened here in the mid-1700s. Enough to, we got it from Lake George, Lake Champlain, up around Lake Placid area up in here. And it looks like it was like a huge, decades-long, massive drought that could have dropped the levels of the lakes maybe 10 feet or more, which would have had pretty big effects on people, you would think, but it's not in any of the history books. So we're calling it the mystery drought at this point, but it shows you that we can have dramatic climate shifts that would be really important to people happening right here at home. And what I hope to do by extending this back to the last 1,000 years is, when was it wet? When was it dry? And when we had natural warm or cool times in the past, how did it affect rainfall? And is there a pattern that we can then use to look into the future and say, well, since the climate models are disagreeing, well, maybe history can tell us what happens here when it warms up. And that's the direction I'm looking at now, is bringing this all down home and applying the deep view of the past to hopefully help see where we're headed here in the future in New York.
Is there anything you'd like to close the conversation with? Any last remarks that you feel really passionate about sharing?
How important I think it is to embrace our place in history and embrace our connectedness to the whole planet and embrace science as one of our most precious gifts. Because, as I said, I consider it our clearest window on the truth. For all its foibles and all our human stuff, this system really helps us cut through the things we wish were true or believe are true that are not. And at this critical time in history, clarity of vision and solidity and reliability of information are just so critical, not just for our well-being, but even for the survival of entire species. So I think it's really time to acknowledge that just learning how to learn, learning how to communicate with other folks, think for yourself, and judge good arguments and good information carefully is every bit as important now in this Anthropocene age as being the person who invents the new technology or the new way of running a society. If we're not well informed, then we can't support these ideas when they show up and can be distracted by things that are wrong. So I just want to welcome everybody to the Anthropocene. Welcome to the realization of how important you are and challenge you to become the best informed and well-intentioned citizen of the planet you can be.
Thank you so much for this conversation. It's expanded my views of how miraculous this living organism that we're a part of really is. So thank you again, CURT.
Well, and thank you for what you're doing. This is very important work.
This has been a conversation with CURT STAGER on Unlearn and Rewild. I'm Ayana Young. The music you heard was Ayahuasca by Don Pedro Guerra Gonzalez. From the River to the Ocean by Hamid Drake and Fred Anderson. The Ocean by Alila Diane. And Pledge to the Wind by Dan Byrne. Our producer is March Young.